Did you get everything to what I taught in last class? Like first principle focus, second principle focus. Can you,
Yes, ma'am.
yeah,
Ma'am, I
can
think I
you,
had a doubt. I forgot.
what doubt you had?
Ma'am, I forgot. I'll just have to check my notes.
Okay, means you went through the notes. That's good that you went
Yes.
through the notes. And in the actually, you can send me your doubts in the WhatsApp group whenever means you send me your doubt instantly. Okay, whenever like you are reading any time. So if you are feeling any kind of doubt, if you are having any kind of doubt, then you can send it in the group. That here I have doubt. Please clear this. So I will clear this. At that time only, or I will clear in the class. Fine. Okay.
Yeah. Yes, ma'am.
Yeah, it would be easier because if you'll send it to me right at that time only, then your doubts will get cleared. Okay. So first principle focus. Can you revise that?
The first and second one, F1, F2.
Yeah. So first principle focus for convex lens. What should it be?
Ma'am, so first principle of focus is it's a point on the principal axis of the lens at which the rays starting from or directed to become parallel to the principal axis.
After refraction. So can you draw this ray diagram for first principle focus or and second principle focus while
Yes,
describing?
ma'am.
Okay, that's great. So we'll go further. Okay, image formation in lenses using ray diagrams. So there are mainly three types of ray diagrams we consider. Okay, so in the mirror also we consider four types of ray diagrams or only three types of ray diagrams, right? Image formation we considered in this four types of ray diagram, right? So describe about this representation of images on the concave mirror. So what it was, the ray that is coming in, that is incident parallel to the principal axis, after reflection it passes through the focus. Okay. The second was the in the incident ray that is passing through the focus after reflection. After reflection, it it becomes parallel to the principal axis. Okay. The third was the incident ray that is passing through the center of curvature of the mirror and goes to reflect back along the same path. Okay, reflect back along the same path on striking the mirror surface. Okay, and the fourth one was the ray that is obliquely to principal axis towards the pole P of the concave or convex mirror is reflected obliquely towards following the laws of reflection. Okay, following the means that the ray that is coming towards the pole of the mirror, yeah, towards the pole of the mirror, reflects obliquely following the laws of reflection. That is, angle I is equal to angle R. Okay. Now, for reflection, where is it? For lens image formation. For lens image formation, we have three. Hello, Sophia. Hello, Sophia. Why you joined so late, Sophia?
I had some connection problem. I'm sorry about that.
Okay, so image formation in lenses using ray diagrams. So in ray diagrams, we will study how many types of rays we will going to make while making the ray diagrams. Okay, so three types of rays we have to consider. The first one is the ray. This one is your optical center. This one is your F1. This one is your F2. This one is your This one is your 2F1. 2F1, why? Because it's C, right? C is what? It's actually 2F. Now R is what? It's actually 2F. So at the point of C, it will be 2F1. Okay. In lens, we write 2F1 and 2F2. It will be 2F2. Okay. So the first line is the first ray is the incident ray that is coming parallel to the principal axis after what? After refraction, it passes through the second principal focus of the mirror. Okay, and again from the below of the principal axis, we make two lines. The ray that is parallel to the principal axis after refraction passes through the focus. Okay, fine. Is it fine? So in this it has only drawn one ray. It's okay. Okay, you can also do that. For concave mirror, for concave lens, for concave lens, the ray that is 2 to f2 f1 to f1. This is your optical center. Okay, the ray that is coming, that is passing parallel to the principal axis, the incident ray that is passing parallel to the principal axis. After refraction, you show the refraction just from the middle of this lens. Okay. After refraction, it will appear to come towards the. It will appear to meet at the focus. It will appear to meet at focus, but actually, what it will do? It will get refract. It will get divert. Okay. It will refract in such a way that it will get divert. Okay. Fine. So the ray that is coming parallel to the principal axis, okay, parallel to the principal axis, after refraction, it will appear to come towards the focus, but actually what? It will get divert. And if we will this join the line towards in the back side, then what it will do? It will appear that it's coming towards the focus. Okay, fine. Is it fine or not? Again, you can make it from below of the principal axis. Is coming parallel to the principal axis. It will divert in such a way that it will appear that it is meeting at focus. Okay, so this will be your solid line and this will be your dotted line, because it's just like appearing. It's appearing to get into this point. Okay, but in actual, it's what it's doing. The ray is getting diverted. Okay, fine. Okay or not? Okay. Second ray. This is your first. Now second. Okay. Second one is what? The ray that is coming from the ray that is coming, passing through the focus of the lens. After refraction, what it does? It goes parallel to the principal axis. Okay, just same as that of the mirror. Okay, it's just same as that of the mirror. So when a ray of light passing through the focus, ray of light passing through the ray of light passing through the focus, after refraction, it becomes parallel to principal axis. Okay, it becomes what? Parallel to principal axis. Then for what? For concave lens. For concave lens, the ray that is directed towards the principal focus, what will be directed towards the principal focus? This directed towards the principal focus, it will what? After refraction, it will become parallel to principal axis. Okay, parallel to principal axis. Is it fine? Rudra and Safia, is it fine?
Yes.
Yes.
Getting the rays, how it's going and how it's getting refracted. It's just same as that of the mirror. Okay. Now the third one is what? Ray directed to optical center will emerge out undeviated. Okay. Just as that of the pole. No, not pole. That of the center of curvature. So what it will do? It was actually for center of curvature. Ki whatever light will go from come towards the center of curvature, it will what? It will reflect back along the same path. And here and for optical center, for pole, what it was, when it will incident on the on the pole of the mirror, it will fall obliquely on the pole of the mirror and will reflect obliquely, following the principle of following what? Law of reflection. Okay, that is sin is equal to sin r. Now here this ray is different. That what it's doing, this is your optical center, this is your f1, this is your f2. Either you show 2f2 or 2f1, it will be same, because here we have no work with this 2f part. Okay, we have no work with that. So the ray that is directed towards the optical center will emerge out undeviated. Okay, the ray optical center will emerge out undeviated. Okay, is it fine? Fine or not? And same will be with what? Concave lens. The ray that will directed towards the optical center will emerge out undeviated. Okay, it will act as what? Why it's getting why it's coming out undeviated? Rudra, can you tell me? In mirror, it was also the same with the when the ray was directed towards the was directed towards the center
Ma'am,
of
it's because it's
curvature.
passing through the center of curvature.
Yes,
Ma'am, it's because it's passing through the center of curvature.
it was passing through the center of curvature. It was just and why it was making why it was directed to means why it was reflecting back along the same path. You only told me the answer, right? When the ray was like in this image formation, for this, it was directed towards the same path. Why? In this case, why? The C point was acting like what? This ray was acting like what? Normal, isn't it?
Yes, ma'am.
Just like normal. Normal does what? In normal, if this is a suppose this is a what we say glass slab. Okay, glass slab. So what is the normal in this? Just 90-degree, right? And what the normal does? It just passes through the slab undeviated, right? It's just a ray, na? Normal is also a ray, na? Or not? Normal is also a ray or not? Sophia? So you will tell me the answer of key. You will tell me the answer of why it's going undeviated. Okay? This is your homework. Why it's emerging out, why
Ma'am,
the
because it's
incident ray
right. The incident ray is acting as a normal.
is acting as a normal, right? So
Yes.
this is what I'm asking, huh? This is what I'm asking. Yes, correct. So okay, fine. Sophia, fine. Why it's getting why it's done this incident light that is directed towards the optical center is emerging out undeviated. You got it? Why it's emerging out and undeviated? Safia, I'm asking you.
Yes, ma'am.
So have you got it? Why it's emerging out undeviated?
No, ma'am.
So what right now what Rudra has told? Key the same as that of the mirror while it was coming towards while it was the incident ray was on passing through the center of curvature. The same will be for this. This ray is actually is acting as a normal ray. Normal. What does the normal do? What does the normal do in the glass slab? What it does? It is the normal light, right? It is the normal, no? That falls 90-degree. That makes 90-degree to the surface, with the surface, right, of the mirror. And and does what? Tell me. It just refract along. It shows no deviation, right? It shows no deviation. Normal shows no deviation, right? This is why this is acting as a normal. This incident light is acting as a normal. That is why it's not getting deviated. Okay? It's just following the same path. It's not perpendicular, but it's not seeming like it's not perpendicular, but there is something that is it's this ray is acting just like it will be the ray has crossed this lens undeviated. So this ray is known as what? Normal for this what? For this lens. Okay?
Ma'am, but all rays that pass through the optical center, all of them, they come out undeviated, so all of them will be normal.
For any point, like you want to say, yeah, you want to say this is like this is normal, right? This may be normal, right? You want to say this only, no?
Yeah.
Right, coming from this point, this may be normal. It is actually, see, it's these all rays are coming to this lens. Okay, fine. So all are coming to all are making all are coming to this surface falling on the lens at different surfaces. Like here it's at different point of the surface. Here it's falling at this point. This ray is falling at this point. This ray is falling at this point. So points are different, right? Points are different. Just like you see this circle. This circle has got the tangent. Circle has how many tangents? A lot means infinity tangents. At every point it has some tangents. At every point it has some tangents. Isn't it? And all tangents makes 90-degree with the radius. Isn't it? Does it make or not? Because all the tangents that is crossing through this what we say through this circle at different points, isn't it? So this is the part of the circle now. If you see one part of the lens, this is the part of the circle, isn't it? Like in circle, are you getting my point or not? Like in circle, all tangents, there are infinity tangents, isn't it, Safia? Can you make
Yes,
infinity tangents? And all tangents make 90 degree with what? With the radius. Okay, all tangents make 90 degree with the radius, right? Because the all tangents are passing through different points of this circle. This is same as that of this mirror. All the lines that is falling on the surface of the on this sorry, every time I say mirror to the lens. Okay, so all the incident light that is getting incident on the surface, on the different surface of the what lens. All of the lights are making. Are you getting this point or not? All the lines are getting different points on the lens. So all of the line that is passing through the through the optical center will pass after refraction, will pass undeviated. You got this?
yes, ma'am.
Okay, fine. Because all are experiencing different points. All lights, all rays are experiencing different points. Okay, and you can also explore more on this. Okay, so you all have to explore more in this. In this part, you both will explore more about this. Okay, gather more of the information about this. Why it's getting what uh, passing undeviated. Okay, this will be your main homework. Fine. This one, this is the reason that I have told you. Okay, this is the model for this lens, and also you gather some of the information about this ray. Okay, it's not necessary that you explore, but it would be great if you explore more about this ray. Okay, ray diagram. So we study now the formation of images. First one was the ray that is coming parallel to the principal axis will pass through the focus. The ray that is coming to the that is directed towards the focus of the lens, the will after refraction will pass parallel to the principal axis, and the third one is the ray that is directed towards the optical center will emerge undeviated. Okay, fine. There are three rays, so we'll use these three rays to draw these ray diagrams. First one, formation of image by convex lens for different position of objects. Now we will place the objects at different positions and then see where the images are getting formed and what is the nature and what is the size of the image. Okay. So first by convex lens. Just as in the mirror that we first studied about the concave mirror, and convex mirror only was forming two images, only was forming two types of images, right? And in this also we will study in the same fashion, but the thing is reverse is that convex lens will form more of the images, will form different, means will form the images at different points with a different size and nature. Okay, and what? And for concave lens, it will form only virtual images. Okay, just as convex mirror. Okay, fine. So we'll start doing this. First, at infinity, we'll place the object at infinity. So when it means putting the object at infinity, it means that the rays are coming from the infinity. The rays are coming from the infinity means parallel to the principal axis. So all the rays are coming parallel to the principal axis will pass through the focus. Obviously, will pass through the focus. Okay. Now beyond 2f1, now we will place the image object beyond 2f1. Beyond 2f1 means beyond C. The C of the lens is called 2f1 here. Okay, 2f1 means f and double of 2f and double of f, that is 2f. This is your radius, right? And this is your point C. Fine. So in instead of writing C, we write here 2f1 and 2f2. So what we'll write? We have placed the object beyond 2f1. Okay. So beyond 2f1, the only two types of rays we will draw. First ray, the ray that is coming parallel to the principal axis will pass through the focus. The second, the ray that is directed to the optical center of the lens will pass undeviated. Okay, will pass undeviated. Fine. Now for the third. Third, we will place the object at 2f1. We'll place the object at 2f1. What it will do? The same types of ray diagrams we'll draw. First, the ray that is coming parallel to the principal axis will pass through the focus. The ray that is what? Directed towards the optical center of the mirror, of the lens, will pass undeviated. Okay, and then the image will form where? At where? 2f2. And here the image was formed between f2 and 2f2. When the object was before 2f, the image will form before 2f. Okay, when the object has just shifted a point, means the object, we have put the object at 2f1, the image will also form at 2f1. Just like in the mirror, that when we place the object at c, we were getting the image right at c. Were we getting or not? Yes, no? Say yes.
Yes, ma'am.
Yeah. Okay. Between f and 2f1. Now we will shift the object a little bit more. Between f and 2f. This f and 2f. F and 2f. So how means we have placed the object. We have placed the object after 2f and before f1. And the means after 2f. Right? After 2f, it means the object will also form. The image will also form after 2f. Do you see this? The image is also forming after 2f, means beyond 2f. Okay, beyond, and it will be what? A little bit larger than that of the object. The image will form a little bit of larger than that of the object. Okay, and in first case, I forgot to tell you. Okay, in first case, in the very first case, the object was the image was forming point sized. Okay, in the second case, the image was forming a little bit of diminished than that of the object. Okay, and in the third case, when the object was placed at 2f, the image will form right at 2f2, and it will be of the same size as that of the object. And for the means gradually the images are getting what? Enlarged. Images are getting enlarged. When the object has got shifted point like between 2f1 and f1, so the image that is forming is quite magnified, and all will be inverted. All the images will be inverted. Only in one time, only it will be one case only when the image will form erect. Okay, so when the object is at f1, the image will form at infinity, because the ray that will make will become parallel means both of the rays will become parallel and will not meet at any point. So we'll say the image will form at infinity. Between lens and f1 means this f1 and this lens. So the image will form how? On the same side of the lens. On the same side of the lens, when the image is formed, then what will happen? It will be what? Erect, magnified, and virtual. Erect, magnified, and virtual. And we'll revise it once more in the next class, and we'll study about the formation of image for concave lens. Okay, fine. So bye for today because time is up.